Hello there, and welcome to day 71 of the 100 Days Python Programming Challenge. It is 71 days. Why are my eyes so big? It's 71 days, and today I will be talking about encrypting and decrypting your data in Python, and we will be using the Cryptography library in Python. So, let me show you how you can encrypt your data and how you can also decrypt it. It's day 71. 71! Can you believe that? It is 71 days. Like, I'm serious, it's 71. Okay, now I'm acting like a crazy person. To the screen. Hello, everybody, and welcome to day 71 of the 100 days. There are 29 more days to go. I think we can start a countdown. 29 more days to go. And then, what is our topic for today? Data encryption and decryption. Encryption is the process of converting your plain text into a ciphertext in order to protect sensitive information, while decryption is the opposite. You're converting your ciphertext into a plain text. And then there are different libraries that you can use in Python. And then I will be using the cryptography library. You can check the documentation. Nothing that I'm doing today is out of the ordinary. I'm just following exactly what the documentation said. So check out the documentation to learn more about cryptography. So let's begin. You have to install cryptography if you don't already have it installed in your system. You use pip install cryptography. And then from cryptography.fenet, I'm importing fenet, and that's what we'll use throughout this tutorial. We'll be using the fenet library. So the first thing that I want to do is that I want to generate a key, which is what you see in the documentation. That is the first thing that I want to do. And how do I generate the key? I use the fenet.generate key. So the fenet that we imported, I hope I'm pronouncing it correctly. Fenet. From the fenet that we imported, I will use fenet.generate key. The generate key method would generate a random key that I would use for my encryption. And this key is very important because if I want to decrypt the message later, this is the same key that I would use. The generated key, it is printed in its raw byte format, and it must be kept safe because without it, your message would not be decrypted. So then the next thing that I would do would be to create a Fenet object. What is a Fenet object? The Fenet object is created using the generated key. This object is what I would use to perform my encryption and my decryption operation. The cipher object is now ready to encrypt or decrypt messages using the key provided. So what message do I want to encrypt? I just want to encrypt a simple message. You can change it to whatever text you want, but this is my simple message. Hello, this is a secret message. And then how do I now encrypt it? Remember, we're using the cipher, the object that we created. So then I would call the cipher dot encrypt message. And then I also want to print out the message. So my message is a string, but since Ferrite works with byte, it needs to be encoded into a byte string. That's why we have the B in front of my string. And then the encrypt method, that's the method I called encrypt the message using our generated key. And then it will then return a ciphertext, which is the encrypted version of the original message. The ciphertext is a byte string. It looks like random characters, so it should just be random characters together, and then I want to print it out so I can see it. The characters will not be readable to you. Even the length of the characters will be so long. You'll be wondering that, oh, just for this short message, I have this much character. And let me print it out so we can see what this is the key that we generated, and this is the text. You can see this much character just for the string. So then what if I want to decrypt the message? The message is to decrypt the message is so simple. We use cipher.encrypt. To decrypt the message, we'll use cipher.decrypt. And then So it says cipher.encrypt. We'll use cipher.decrypt. But then, here we just called our cipher text. What is cipher text? Well, the message, cipher.encrypt message, and then our plain text, cipher.decrypt cipher text. That is the cipher text that we got. And then we want to print it. We'll use the plain text dot decode. The decrypt method decrypts the cipher text back to its original message using the same key that was used for encryption. The result is also in byte format. So the decode method is used to convert it back to human readable string, and the plain text will then print it out. So let me run this again. You see, we have our plain text printed out exactly the same way our message is. So this B converts our message to a byte format, and then this decode converts the byte format back to a plain text that you can understand. So the things we used here is the finite to generate our key. We then created an object, and then we use that object dot encrypt and the object dot decrypt to encrypt and decrypt our message. So we just worked here with plain text. What if we want to use a file? We can also do that with a file. So you can generate a key and you can save that key into a file. So still the same method, just that instead of printing it to the console, I would write it into a file. So I will use my with open to write in the file. I know here we're using this byte format. So instead of just using W, which is the mode for writing, I will use WB because I'm trying to write into the file, write byte format into a file. So this is my simple code that generates the key and then it writes it into the file. So the generated key is saved into this file, and the WB mode indicates that the file is opened in a binary write mode, which is necessary since the key is in byte format. So then after I have my key in the file, I can then read the key. You can just simply with open the secret key file that we created and then read it. And again, because it's in byte format, we'll read it using RB, not just R. And with open, because we don't have to close the file after we open, we don't have to use file.close. With open, automatically does that for us. So after storing the file, the key, the code opens the secret key in binary read mode and reads the key back to the program. So then we can use it later to encrypt and decrypt the file. So then the next process would then be to create our object, our finite object, the exact way we did it here. So I would have cipher equals to finite.key. So the exact same way that we created our object, we'll create it here. And now it's time to encrypt a file. I have a txt file with open example.txt, and then that is the file that I want to encrypt. So I would read the information from that file, and then I would encrypt the file, the information that I read, and then I would save it in a file, and then I would then also decrypt the encrypted information and also save that into another file. So let's have that. It's the same with open that we're using. So this is my example.txt. I want you to read the file, the encrypted data, cipher the object dot encrypt. What are we encrypting? The data that we read from the file. I will then open this file or create this file example.encrypted, and I want to write into it. What do I want to write into it? I want to write the file that the information that we encrypted, I want to write it into this file. And after I've written it into this file, I then want to decrypt the information and save it into another file. So I want to now open this example.encrypted and read the information, decrypt it, and save it into an example.decrypted.txt file. So let me go over the process again. We have our first file that we're going to write our secret key into it. And then we're opening the file to read the secret key so we can use it in our code. And then I have an example.txt file that I'm trying to read the data. And the data that I read, I'm reading it in binary RB because I want to call my cipher object to encrypt the information that is inside my example.txt file. And then after it reads the information and encrypts it, I now write the information into my example.encrypted file. And it's WB, that's my mode. And I write that information, and that is done with the encryption. So now I want to decrypt the file. I want to change it back to the original text that is in my example.txt. So I open my example.encrypted. I open it in the mode RB. I read the file, and then I call my object, my cipher object dot decrypt to decrypt the information in my example.encrypted, and then I write it into my example.decrypted.txt. And when I run this, you see we do not get an error. Let me show you the content in all the files. So these are my files. This is my secret key, the secret.key file that we created initially in the code. This is my secret.key. And then we open the file to read the secret.key. And then we're applying decryption, the encryption, sorry, to the example.txt. This is the information that I have in my example.txt. I don't know why I have LOA. I don't know why, but that's what I have in the file. And then open this file to read it, and then I encrypt the file using my cipher object, and then I write my information into my example.encrypted. This is my example.encrypted. This is my encrypted data. And then I open this file to read it, and then I apply the decrypt, the cipher.decrypt, and then I save my information into an example decrypted.txt. And this is the final result. Yeah, I still have the LOA. I don't know why. So that is what we've done today. I've showed you how you can use the cryptography to encrypt and decrypt your code, your information, your secret information, and then there are practice questions for you to try out. And see you tomorrow for day 72. That is it for this video. Do not forget to subscribe, to like, and leave a comment. Let me know if you have any questions. And as always, the link to the Jupyter notebook is in the description. See you tomorrow.